Hi everyone, thank you for attending our webinar where we'll be talking about modernizing your data infrastructure with Looker and Amazon Web Services. We're really excited to be here because we're looking forward to sharing some exciting new strategies to get more out of your AWS instance than ever before. So today, what we're going to be doing is going over 3 areas of focus specifically for a typical AWS admin. The first is database optimization, specifically on an Amazon Redshift database. We'll be talking through, first and foremost, what to optimize and then how to optimize it. We'll also be talking through cost and usage optimization and security and monitoring with AWS Cloudtrail logs. But before we get into that, we're just going to give a couple of introductions about ourselves. So my name is Kenneth Kunanen, and I'm a Product Marketing and Analytics Manager here at Looker. I'm also a database expert and the producer of Looker's Pocket Guide to Databases, which is available at databases.looker.com, and I'll be talking to you guys about Redshift Optimization specifically today.
Great, thanks for that. My name is Dylan Morrison. I'm a product manager on our data platform side. I oversee our blocks program, which is what we're going to be talking about a bit today as it relates to AWS.
Awesome, great. So before we get into talking about AWS, we want to talk a little bit about the Looker data platform. So many of you guys attending the webinar today already have a massive database probably built on AWS, or you're thinking about building, your database and moving your data infrastructure to AWS. You probably use this database to centralize, disparate data in your organization coming from cloud services, ad hoc reports, and maybe also transactional databases. What Looker is essentially is a data platform that sits on top of that database that makes it easy for analysts in your organization to model and govern access to that data in this centralized database so users can easily access that and build insights from that. So by essentially abstracting all the relationships in your database and surfacing it to users in the form of tables, charts, and dashboards, what we've really found is that that abstraction of these relationships contained in the database, companies can really surface that data that was previously locked down to greater numbers of end users in the form of operational dashboards, ad hoc reports, scheduling, alerting, or even data delivery to other systems. And Looker's powerful self-service capabilities really allow users, any users in your organization, whether they're technical or non-technical, to really easily dig into these reports and dashboards by really slicing and dicing that data to learn more for themselves. And we'll show you a little bit more about how that process works, specifically with some of these use cases with AWS that we'll be talking through later today. So in some cases, the data coming from the individual data source is so templated that we're able to write an analytical workflow, an analytical pattern that anyone with a Looker instance can use and deploy that workflow in their own data set. So we package these analytical patterns and workflows into a set of deployable code that we call Looker blocks. And really the 3 things that we see Looker blocks doing is really taking the analytical workflows from some of the best data experts in the world and dropping those workflows right into your own workflow. So they really help accelerate your analytics, taking some workflows that might have taken you hours, months, days, or even years, and dropping them in minutes into your workflow. So, in some instances, we've actually collaborated with the experts that have created the data sets themselves, as is the case with, the Redshift Optimization block, the security and monitoring block, and the cost and usage blocks that we've collaborated with, specifically with Amazon on. And so really what this means is that you're really getting the most relevant analysts and product experts in the world and data experts in the world to help you get more value out of your data set. So because you're sort of relying on the expertise of people that are really intimately familiar with that data that you're using, that really enables you to reuse their analysis so that you don't have to do that upfront work yourself, and you can really focus on tailoring that code directly to your use case. So with Looker and Looker blocks, what you're first able to do is really amplify your team. Allowing anyone that really needs to be given access and essentially specifically for the AWS Console, which is locked down and only available to admins. What Looker blocks allow you to do is really allow anyone that needs to be able to access and troubleshoot Redshift performance or cost and usage or database security to be able to do that and have access to that information in a really fine-grained self-service way without having to either be given access to the AWS Console or go through administrators that might have access to the AWS Console. So it really reduces those bottlenecks. Second, it's really one unified interface that provides value to everyone, that allows you to kind of simplify and distill your workflow. When you're going back and forth between multiple contexts and you're context shuffling, that's actually kind of a pain point in the sense that you're going back and forth between multiple applications, and you're using one application to maybe perform some diagnostic analysis and another to actually take action. With Looker, what you're able to do is really have that one unified interface that allows you to diagnose and also prescribes value and then allows you to take action all on the same platform. Third and finally is that you're able to really prioritize and focus your optimization efforts by using Looker as a self-service technology to slice and dice your AWS data in a way that, again, is very simple and allows you to ask better and deeper questions than ever before. So with that in mind, we're going to talk about how to optimize Redshift using specifically the Redshift optimization block. But it's really also important to note that, across this webinar, there are going to be strategies that we are going to be talking about that are going to be using the Looker blocks in this webinar as a framework to guide those decisions. But it's important to note that even if you're not a Looker customer, these are strategies that you can apply in your day-to-day. And so we're making sure to ensure that this is value that you can take out of the webinar. But also, if you want to apply it Looker, you understand how that workflow functions. So in the case of the Redshift block, we built an analytical workflow right from the Redshift system tables. So since these tables are standardized across all instances of Redshift, this block can be implemented super quickly. So I've implemented this block myself, and it's taken me about 3 minutes. That includes a couple of very custom-built patterns from monitoring network patterns, join distributions, and things like that. All of which I would have had to build myself if I didn't have this block available. And so it's important to note that there are no real customizations for this block that are needed beyond specifically specifying the connection and connecting your database to this block. And so, as I just alluded to, one of the major benefits of the Redshift block is that it will really help you focus your optimization efforts and know what exactly needs to be optimized, across your data warehouse. In this case, really knowing what to optimize is pretty much half the battle. So, in terms of this, I think we want to talk about first by seeing, some of the common pitfalls that really befall a lot of people. Which are definitely practices that probably do a lot more harm than good. And obviously, I think a lot of these you probably notice some of these and understand to avoid them, but it's still tempting sometimes to do these in practice. So obviously, you don't want to optimize tables or schema in a vacuum. What you do want to do, especially given the nature and the functionality of Amazon Redshift, is optimize these based on actual query patterns. You really want to understand how your users are using your data, and really co-locate and optimize your tables based on their usage, rather than trying to attempt to understand how they're going to use it beforehand. And so again, really what this is a waterfall approach, right, where you're trying to assess all your user needs beforehand. And what we're saying is that this is really a constant process that you want to do when you're a Redshift admin. To consistently iterate on your performance and understand how your users are querying your database, so that you can make those slight incremental tweaks that provide a lot of value and reduce a lot of bottlenecks on the back end. And so obviously, you don't want to prematurely optimize your data. You really want to respect that of your own time and that of your colleagues, which of course means that you don't want to spend all this upfront effort if that's not necessarily going to be used. So really, what we want to do now is get into a little bit more specifics. So how does the Redshift block really help you efficiently iterate on actual query patterns. So what we've actually built with Looker is, inside Looker is this Redshift performance dashboard that's available with this block. And this dashboard is really your go-to and home base that you can use as a starting point when proactively working on Redshift optimization. And so there are several tiles on this dashboard that show patterns and cohorts of queries. Obviously, on the left, you have a query time histogram that shows you, at a high level, which queries are going to, where your overall performance lies with your Redshift instance. And obviously, you want something that looks a little bit more like the one that we have showcased, which is the vast amount of queries are going to be taking, sub 1 second, sub 5 seconds. And only a small amount of queries are going to be taking, more. And which with declining, return time as you get up into, the minute, 2-minute mark. You also have, cohorts of queries, and such as the top 10 running queries, right? And so this is actually incredibly useful when you're trying to look at specific queries that people might be running consistently that are taking a really long time to run. And so really what we've tried to do is make this block both descriptive but also prescriptive to give you an idea of where to prioritize and focus your workflow. Moving down the block, there's also 2 patterns that we think are particularly useful, which are the patterns that are talking about network distribution. So, these 2 patterns on the left, we see you first have this pie graph that shows the overall share of network redistribution activities needed to perform joins in your cluster. And so everyone that is a Redshift admin knows that, by default, the block really considers, queries that are only run in the past day. And on the right, what we do is we filter for, specifically bad join distributions and break them out by their join conditions. And so this is really useful for 2 reasons. The first being is that, and we'll get into this a little bit later, which is that network redistribution is a very common and very significant issue that can really bottleneck the performance of your Redshift data warehouse if you don't necessarily know how to approach it in the right way. But the second reason, is that is even more important, which is, when you're running queries based on Looker, Looker really tends to produce very consistent join patterns. And so when your users are using the Looker data platform, what that allows you to do is really standardize exactly how those join patterns are getting implemented, and as a result, understand really how to, it gives you a lot better of an idea of exactly that usage of your data warehouse. Great. So, talking now about the tricky half, which is diagnosing the problem and selecting the appropriate corrective action. So really, the first one is, once you find a particular join pattern or problematic query that you really want to know more about, you can really drill in with Looker, which takes you, you can drill in off of this top-level dashboard, and this takes you to a further dashboard that we call the query inspection dashboard. And really, this is where we believe that Looker kind of shines. It brings together all of the query-specific information from your Redshift system tables and brings it together in a really comprehensive view. And obviously, this is available for any query that you decide to drill into from the larger dashboard that shows the aggregate amount of queries that you're running across your instance. And so, really, what we're going to do is rather than going too deep on one subject, we're going to talk about how 2 distinct problems that befall a lot of Redshift admins when attempting to optimize their network activity, optimize their usage on Redshift. One, of course, is going to be something that a lot of people are familiar with, and the other is something that's not as common, but has a lot of very powerful implications. So, going from the first one, which is excessive network activity. The query inspection dashboard is going to really highlight this really well for you, right? It's going to show how many megabytes were distributed or broadcast across the network for a particular query. And so if you see a very high amount for an individual query, you know that one really required a lot of network activity to sort of shuffle data across nodes in your cluster. And this is really the most common issue because Redshift will, by default, set distribution styles as even across your cluster. And so, everything by default is going to have a lot of movement across your database, And this is something that as a Redshift admin, you have the power and control over to optimize as you go forward and learn more about your usage habits. And it's important because this is a huge, sizable, and far-reaching impact. So let's just clear all these. Okay, great. So the way that you can really identify this is looking for, across the in the aggregate dashboard, looking for a high number of distributed or broadcast bytes in the top level metric, but also looking for distribution both, which is both sides of the table are shuffled to produce a join. Distribution outer, right, which is the bigger of the two tables have to be moved around the network, or broadcast inner, which means that the smaller of the two tables needs to be copied to every node in your cluster to the larger table. So in terms of corrected action, what this allows you to do is really identify those network patterns and apply those distribution keys to those tables to allow both, in terms of tables that are going to be used very frequently, co-locating those tables on the same cluster. And obviously for smaller tables, distribution all might be better, but again, it's not a silver bullet because again, that comes with the penalty to scanning. So we're going to go really quickly in through the large nested loop joins. Really what these are is just a join condition that causes the database to sort of brute force the approach to join these two tables. So things like inequality joins are going to produce these, or text matching when the relationship between the two tables, when you don't have a relationship between two tables. So you look for a name inside of a larger text field using the like parameter, for example, the like clause. Or even logical queries that, where you're not necessarily constraining as two things being equal, but really saying something, either this or this can happen. And this really shows up in our query inspection dashboard. It's highlighted in red, and it clearly marks that nested loop. So even if this is less common, this actually has a huge impact on performance. So this is something that when we do see it pop up, we want to make this a #1 priority to solve. And so, two of the ways that you can do to solve this is, really refactoring, larger nested loop joins into smaller nested loop joins. Like this is really, you can really do this effectively by partitioning based on dates, for example. So rather using a large nested loop join to join two tables that contain all dates in a certain series, what you maybe want to do is constrain that date field to maybe 10 dates that you're really interested in looking at. And so obviously reducing the size of those tables is going to produce even if the database has to brute force that join, it's going to produce the results in far less time. And secondly, some inequalities might be better to write as a window function. And third, even if you do have to brute force that table, definitely persist that table and persist that relationship so you don't have to execute that live every single time. So really, for those of you that want to know more, both of these answers are documented in our Looker developer community discourse, and we're happy to follow up with you over a call or demo if you guys are interested to learn more as well. So with that, what we're going to do is turn this over to Dylan Morrison, who's going to talk more about AWS-specific blocks.
Awesome. Thanks, Ken. I think that was a really great overview of sort of the administration, optimization of performance, which is one of the critical elements of any cloud deployment. The other two elements that often come up are your cost and your usage, so how much is all of this costing you? And then lastly, you're at security and monitoring, so making sure that your cloud deployment is locked down, no one's seeing things they shouldn't be able to see, all your data is secure. So the first one we're going to look at is cost and usage. So here's a quick overview of the data pipeline we assembled to analyze our cost and usage data. There's actually a report that AWS produces. It's just called the Cost and Usage Report. So what we're doing is just dumping that into S3, and then we're using Athena to query that information and plopping a Looker block on top, which gives us a pre-made data model around this. We're using Athena here instead of Redshift because billing data can get quite large. We've seen some customers, bring up to tens of millions of rows per day. So sometimes it's just easier to handle using Athena. So for cost and usage, we actually work with the team at AWS to identify the 3 most popular cost-saving strategies. Now each company is different, so these might not hold true for everyone, but they should for the majority of users. The first lever is reserved instances, and this is probably going to be the biggest lever of most companies. The important thing to know is that reserved instances are usually around 75% cheaper than on-demand instances. So naturally, we want to maximize our use of reserved instances to be the most cost-effective. To do this, it makes sense to just forecast the amount of instance hours we'll need each month and try to reserve close to that amount. But on the flip side, you don't want to overestimate the amount of hours you'll need. Otherwise, you'll have paid too much, and you can lose your excess capacity at the end of the term. So it's an iterative process to get up there, but at the end of the day, most sophisticated companies end up at about 80% reserved instance coverage. So once you get in that ballpark, you're in pretty good shape. Another obvious but important thing to remember here is that unless you're using a serverless service like Lambda, nearly all AWS tools are using a hosted EC2 instance. So if you're using Redshift, RDS, EMR, all of those are running on EC2. The second lever is data transfers. So one of the great things about AWS is how easy and cheap it is to store data. It's once you start actually moving that data around that things can get a little bit more pricey. So generally speaking, the farther you're moving the data, the more costly it's going to be. Transferring data between different AWS regions is the most pricey. So say from Oregon to Ohio might cost, say like 2 cents a gigabyte or something like that. Oregon to Europe might be around 9 cents, I think currently. And then Oregon to somewhere like Singapore is about 27 cents per gigabyte. So pretty significant increase there. Transferring data within the same regions, but between different availability zones is the cheapest at about 1 cent per gigabyte. Therefore, to save costs, you should try to localize your AWS services within the same region as much as possible. The other factor besides how far the data moves is how that data moves. Transferring data between AWS users and services within the same network is relatively cheap and often even free. Transferring data over TCP, however, to the open web can get pretty costly at about 9 cents per gigabyte. So to the extent possible, you should minimize the amount of data flowing over the open web or through external web applications. The third lever is using custom allocations. So this is probably the most flexible method of cost savings. AWS allows you to apply custom tags to resources, which allows you to just add an extra attribute for analysis. So this one is going to be super contextual based on your business, but can be quite powerful and effective. So what's great about the Looker platform is that not only can we see all this information and perform all this analysis in one place, we can also take action on that data as well. So if you notice some of your instances haven't been used in the last week or month, you can say pause or terminate those instances using data actions directly from the Looker UI. You can also launch a new instance or reserved instance if you need to. Plus, you'll get all the benefits of our scheduler and automated alerting. The next thing we're going to talk about is security and monitoring with AWS. And we have a pretty similar pipeline here to what we assembled for cost and usage. The only difference being that Cloudtrail delivers logs to S3 in JSON rather than CSV. So Cloudtrail is a really great service from AWS that provides security and DevOps personnel with a whole suite of information to perform their jobs better. So once you enable Cloudtrail in your AWS environment, you'll receive logs of each action taken by a user or AWS service. These logs include information such as who took the action, where and when the action was taken, and what resources were involved. So when you're a heavy AWS user, there's huge volumes of actions initiated by users or services such as EC2, VPC, IAM, Redshift, etc. So that means every time someone queries a database, logs into the AWS console, hits an error, or takes any other action, it's recorded as an event in Cloudtrail. And that makes it especially useful for monitoring the type of use of each AWS service and your users. It also makes it great for governance, so you can ensure that there aren't any loopholes in your permissioning systems and that you're always taking the appropriate corrective actions. It can help with compliance, so meeting any regulatory requirements such as data location and movement. AWS actually has a list of how you can use Cloudtrail to meet regulatory needs across a number of different industries, which is really helpful. And then finally for auditing, so Cloudtrail can help you audit across the board. You can track down any troublesome user or services. You can see where the most errors are being incurred, and you can look for things like modifications to security groups and other important permissioning aspects. And so since Cloudtrail provides so much information, it can be used very flexibly for a host of use cases to match your business needs. So in the next 2 minutes here, I'll just walk really quickly through some of these common examples. So one common use case is looking at errors throughout your AWS environment. We can look at errors at a user or service level and answer questions such as, which users or services are taking actions that are resulting in errors. Are those end user errors, or are those things I need to fix? So on the left here, we can see a few examples of a user who has had a few failed login attempts. Maybe that means that they're trying to get into a certain Redshift instance or EC2 instance that they're not allowed to. So maybe you will want to go give them a slap on the wrist. Another use case is looking at all the various errors across your entire environment. So this has quite a few examples that we're running up on time on, so I'll sort of brush through. But this is just showing errors across your whole cloud deployment. What can be really helpful here is looking at trouble with logins. So because potentially hundreds of logins are occurring every day, it's important to identify those that seem to be outside the normal course of business. Some key components to examine with respect to logins are logins that occur outside of our normal network. So to do this, we can examine logins across all IPs and look for any irregularities, such as repeated failed logins from an unknown IP, which could be an indication of someone attempting to penetrate your security settings. Next, we can look at geolocation, and this is really easy to interpret visually. If you're seeing logins from geographic regions where you don't have operations or virtual clouds, that login activity is probably suspect and worth investigating. And then finally, we have logins without using multi-factor auth. So this is looking at the number of failed attempts to log in using MFA. Next action we want to take, of course, is then why is MFA failing for these users? Since we're in Looker, we can drill down to all of those individual events and look up which users were corresponding to those failed attempts very, very easily. So we're just about up to time here. So with that, we will just let you know that we have a host of resources available on our website at looker.com. That goes into detail about each of these use cases in much more detail. We also have a great offer with AWS to provide $1,000 in free credits towards your AWS data warehouse. So if that's something, if you're looking to get started with AWS, this is a really great entry point. And if you're interested, please just head over to the URL you're seeing at the bottom there, discover.looker.com/headstartaws, and we can get you rolling with the credits and get you any resources you need to help better manage your cloud deployment. Thank you.